The next type of problem we look at in example 2a is actually evaluating some of these logarithms, some of these expressions that we are seeing. So the first problem here, we see log base 5 of 125 equals x. So anytime you're trying to evaluate a logarithm, it's helpful for us to think about what that logarithm means. So in this case, the base for our log is 5. We start here, 5 to the x power equals 125. Well, if you have that power table still, it'd be a really helpful thing to look at. I'll have copies for you again in class. But those power tables are good things for us to look at because if we look at our power table, we'll see that 5 to the third power is 125. So in this case, x is 3. The next problem is a little more complicated. So I have log base 4 of 32 equals x, which in exponential form means 4 to the x power equals 32. Again, I'm starting with my base, jumping across the equal sign and jumping back. Well, if you look at your power table, 4 to the second power is 16, 4 to the third power is 64. So somewhere between 2 and 3, what can we do here? Well, something that you might notice is that I could rewrite 4 as 2 squared. That's really 2 squared to the x power because 2 squared is 4. Okay, nothing is really different here. Equals 32. Well, and 2 squared to the x power also means 2 to the, remember our exponent properties say I can multiply these powers together when I have a power to a power. So this is 2 to the 2x power equals 32. Now if we look at our power table, you'll see that 2 to the 5th power is 32. So if 2 to the 5th power equals 32, that means 2x has to equal 5. Okay, 2x has to equal 5. And then we can divide both sides by 2 and get that x is 5 halves. Okay, and we can always remember our rational exponents and what they mean if we wanted to double check here. 4 to the 5 halves, the bottom number is 2, so that means the square root of 4, which is 2, to the 5th power is 32. So we can always check our answer that way. Okay, this third problem that I've written is a very similar process. I have the log base 64 of 1 over 32 equals x. Okay, this looks messy for a few different reasons. Before I start freaking out about how messy this looks, let's think exponential form. 64 is my base. So 64 to the x power equals 1 over 32. Well, at this point, okay, 64 to no power is going to give us 32, not as a whole number anyway. But let's think, how could I rewrite 64? Well, I know I could write 64 is 8 squared, or 4 to the 3rd power, or if you look at your power table, 2 to the 6th. What could I use for 32? Well, 32 is 2 to a power also. We just figured out 32 is 2 to the 5th over here. So let's use this pair. That 64 I could rewrite as 2 to the 6th power. All right. So then 2 to the 6th power to the x is really 2 to the 6x power. And while I'm here, let's think for a second, how on earth are we going to write 1 over 32 as 2 to a power? Well, 2 to the 5th power is 32. So that means 2 to the negative 5th power would equal 1 over 32. Okay, So 2 to the 6x power has to equal 2 to the negative 5th. So if you look at our situation here, my bases are the same. I have a base of 2 on both sides of my equation, so that means 6x has to equal negative 5. And then we divide both sides by 6. So x is negative 5 over 6. Okay, now the same way that I split the 1 over 32 to be 2 to the negative 5th power over here, I could have done the same thing over here. I could have said that 32 is 2 to the 5th. And that's really what I did, okay? That's really what I did here. Because then 2 to the 2x equals 2 to the 5th. Those exponents equal each other. All right. So as you notice here, sometimes when we're evaluating logarithms, it's pretty easy, like this first example. Sometimes it can be pretty complicated.